Okay students, welcome back to another video. In today's video we'll be doing paper 4 of IGCSE physics, October-November 2023. First question says that oil has density 0.80 and water has density 1 gram per centimeter cube, and when oil is poured into surface of water it doesn't get mixed up. So what is the final position of the oil? We know that if they don't get mixed up, then oil will float on the surface of the water. Why it will float? Because density of oil is lesser than the density of water, and we know that if something has a less density, it doesn't get sinked into the other liquid, it just floats on it. So density of oil is lesser than the density of water. The next question says that an irregular shaped solid object has density of 2.7 gram per centimeter cube, and we have to describe a method by which we can measure the volume of irregular shaped solid material. To measure the volume of irregular shapes, we can use a measuring cylinder. So I am just drawing a measuring cylinder here, and after putting the water into it, we have to note the initial volume of the water. After measuring the initial volume, pour the object the volume of which you want to measure, and then you will know the final volume of the water. After measuring the final volume, you will subtract the final volume from the initial volume, and as a result you will get the volume of the irregular shape. Whatever shape you will have, you will get the volume of that shape. Take a measuring cylinder, note initial volume of it, put the irregular shape into it, and then note the final volume and subtract the final volume from the initial volume, and you will get your volume of the object. The next question says that volume of the object is 83 centimeter cube. The object that we poured earlier, the volume of it is 83 centimeter cube, and we have to get the mass of it. And the question has already given us the density of this object as well, which is 2.7 gram per centimeter cube. So the relation that connects volume, mass and density is V equals to mass divided by density. So I am using this equation. I will arrange this equation making mass the subject, so density and volume will get multiplied. The volume of the value of volume is 83 times 2.7 is the density. I'll multiply these together, and I'll get mass as 220 grams, and I'm just writing into the place. And make sure your value should be two significant figures only, and I have just arranged my answer to two significant figures this time. Next question says that figure 2.1 is a graph that shows how the extension of spring varies with load suspension from it. Determine the spring constant of the spring. We clearly know that Hooke's law has related extension with load, and Hooke said that the extension produced in a spring is directly proportional to the load applied to the string. I am just writing this equation as F directly proportional to X. Removing the proportionality sign, I'll write the constant, which is spring's constant. So from here we can get that what is the equation of spring constant. Spring constant is equals to the extension at the load divided by the extension at any certain point on the graph. So I am just taking the points that the question has given us. So at this point we see that the load is 14, so I'll write 14 in place of F, and the extension is 4 centimeter, but let me just convert this into meters, and it would be 0.04 meters. Dividing them both will give you 350 Newton per meter. I'm just writing it into the place provided. 350 Newton per meter is the final answer, and it is the spring constant of our spring. Now the next question says that figure 3.1 shows a boy throwing a ball at the object in fair ground. The ball has mass of 190 gram and it travels horizontally with the speed of 6.9 meter per second. We have to calculate the momentum of the ball. As we know that momentum is equals to mass of the object times the velocity of the object, and they have already given us the mass of the ball, which is 190 gram. Let me just convert it into kilogram. It would be 0.19 kilogram times 6.9 meter per second, and the final momentum of the ball would be 1.3 kilogram meter per second. Writing it into the place that is provided. After hitting the object, the ball bounces back along the same straight path with the speed of 1.5 meter per second. The object has the mass of 1.8 kilogram. We have to calculate the speed of the object after the ball hits it. Okay, so let us just consider the scenario again. There was a ball which was lying on this table, and the boy hit the ball towards this object with the speed of, the ball has the mass of 0.19 kg, and the boy throw it with the speed of 6.9 meter per second. After the ball hits the object, the ball bounces back in the opposite direction with the velocity of 1.5 meter per second, and as a result of this collision, the object moves forward with the velocity we don't know. We have to get the velocity, and this object has the mass of 1.8 kg. For collisions, we can use law of conservation of momentum. So momentum before collision equals to momentum after collision. So momentum of ball before collision plus momentum of object before collision equals to momentum of ball after collision and momentum of object after collision. We know that momentum of ball before collision was 1.3. We have just calculated it in part A. Momentum of ball is 0 because it was at rest. After collision, the ball has the momentum mass times its velocity. So mass is 0.19 and velocity is negative 1.5. Why? Because it is traveling in the opposite direction in which it was earlier. And momentum of the object is 1.8, which is mass of it times velocity of it, but we don't know the velocity. I am just writing v in place of velocity. I'll arrange the equation and solve the equation. 0.19 times negative 1.5 would be negative 0.285 plus 1.8 v. Making the v the subject, you'll bring every other thing to opposite side of the equation, and equation will become 13 plus 0.285 divided by 1.8. And when you put all these things in your calculator, you will get 0.9 meter per second as the velocity of the object after collision. Next question says that the kinetic energy of ball is 4.5 joules before collision and 0.2 joules after collision. We have to calculate change in kinetic energy of the ball and the object during the collision. Again, we'll go with law of conservation of energy. Kinetic energy before collision is equals to kinetic energy after collision. Kinetic energy of ball before collision plus kinetic energy of object before collision equals to kinetic energy of ball after collision plus kinetic energy of object after collision. We know kinetic energy of ball before collision is 4.5 and kinetic energy of object is 0 because the object was at rest, and kinetic energy of ball after collision is 0.2 joules, and kinetic energy of object is not given, but we know the formula and we can put the values. Half mv square. In place of mass, I am going to put the mass of the ball, which was 1.8 kg, and in place of v square I am going to put the velocity of the ball that we have just calculated and square of it. Doing the calculations, 4.5 plus 0 would be equals to, we'll solve all these things together in the calculator and we will get 0.91 as an answer. And we know that energy has shifted from 4.5 to 9.1, so it is 0.6 joules. Next question says the lowest possible temperature is 0 Kelvin. State the name of this lowest possible temperature. We know the name of the lowest possible temperature at which kinetic energy of molecules becomes zero is absolute zero, and it is the lowest possible temperature. So I'm writing absolute zero in the space. Next question says nitrogen boils at 77 Kelvin. We have to convert this into Celsius scale. We have to convert Kelvin into degree Celsius. And to convert Kelvin into degree Celsius, we have to subtract 273 from the temperature, which is in Kelvin, and we'll get the answer in degree Celsius. So 77 Kelvin minus 273 will give me negative 196 degrees Celsius. So 77 is equals to 196 degrees Celsius. Next question says the temperature of fixed mass of gas at constant volume changes from 300 Kelvin to 400 Kelvin. State and explains in terms of the pressure of the gas. Basically, we have a volume of gas like this, and we have changed its temperature from 300 to 400 Kelvin, but we haven't changed the volume of it. So what will the temperature do? The particles will start moving more faster, and they will hit the walls of the container more often. This will increase the pressure on the walls of the container. Writing all these things into explanation, changing temperature, the kinetic energy of molecules increases. The molecules hits the wall of the container more often, and pressure increases. Writing this in the statement as well. So changing the temperature, the pressure will increase. Next question says a sample of gas is at pressure 120 kilopascal. The volume is doubled. That means the initial volume was V and then the volume become 2V. At constant temperature, calculate the new pressure of the gas. Whenever you see the term constant temperature, you can use Boyle's law. P1 V1 equals to P2 V2. P1 is initial pressure, which is 120 kilopascal. V1 is initial volume, which is V. P2 is the new pressure that we don't know, so I'm just keeping it as it is. And then V2 is twice the initial volume. Arranging the equation with respect to P2, it would be 120V over 2V. VV will be cancelled out. 120 divided by 2 would be 60. 60 kilopascal is the new pressure. And it is obvious that when volume doubles, pressure halves. Next question says that figure 5.1 is a scale drawing of wave fronts of red light approaching a gap barrier. So this is a red light, this is a gap, and the wave fronts have to diffract from this gap. So we have to draw 3 wave fronts after the diffraction. We can see that the gap is compared to or lesser than the wavelength, so the diffraction pattern would be circular, and the wavelength after diffraction will remain same. So you can bring your compass, place it into the middle of the gap. You can draw the first diffraction pattern by your choice, and then you have to draw the next patterns by measuring the wavelength, and the initial wavelength and the final wavelength should be equal. The gap between the wavefronts would be equal. So so be very careful when you draw these patterns, and you can see my circular patterns are equally apart as they were before. So this is the diffraction pattern of red light. Next question says that now we have to diffract a blue light. Instead of red light, we have to diffract a blue light. That means that this time our wavelength would be shorter than the wavelength before, and we have to draw 3 wavefronts before it reaches the barrier, and we have to draw 3 wavefronts after the wave passes through the gap. So this time we know it's a blue light, so our wavelength should be shorter, so the wavefronts would be narrower than before. Drawing the first line, straight line, and then the next straight line, making them a bit narrower than the previous case. And I have drawn the 3 wave patterns, but make sure they are equal distance apart. But we need to know few facts about wavefronts, that they should make 90 degree with the wave. That means this is 90 degree, this is 90 degree, and this is 90 degree. And the next thing, that they should be same distance apart. This can't be happen that two wavefronts are narrower and two wavefronts are apart from each other. This time our gap is greater than the wavelength of the light. So that means our diffraction pattern won't be circle anymore. It would be a kind of this. The wavelength would be same, but the diffraction pattern won't be circle anymore because the gap is greater than the wavelength this time. So I have drawn the three patterns of the diffracted wave, and they have the same wavelength as earlier, but pattern is changed. Moving to the next question. The question says that sketch a current voltage graph of a filament lamp and explain its shape. We know that the filament don't obey Ohm's law, and the voltage and the current are not linear with each other. So the pattern of filament looks like this. And why it look like this? Because we know filament, when current passes, gets heated up, and when it gets heated up, the resistance rises, because the resistance is directly proportional to temperature. And when the resistance rises, it blocks the flow of the current, and the current reduces, so the linearity relation is affected. Next question says that figure 6.2 shows a circuit in which there is a 12-volt battery and 3-volt battery, which are connected to resistors and diodes and a voltmeter as well. And we know that current flows from positive to negative terminal. So for this 12 volt, the current will flow in this direction and it will pass through this diode, but the other diode is reversed biased, so the current won't pass from it, it will block the current. And for the 3 volt battery, the current will flow in the opposite direction because positive terminal is at that side. So for this battery, the current will flow like this. And we know that this diode don't let the current to pass, so this resistor is not going to receive any of the current. I am mentioning it before. We have to calculate the reading in the voltmeter. The voltmeter will read the net voltage. So 12 that side, 3 that side, so I'll subtract the both, and the net voltage would be 9 volt. So this is the reading that will come in the voltmeter. The next question says that you have to calculate the current in 4.2 ohms resistor, that means this resistor. So we know we can use Ohm's law to get the current. Ohm's law states V equals to IR, and I would be equals to V divided by R. We have calculated the net voltage, which was 9 volt, and the resistor is 4.2 ohms, and dividing both numbers together will give me 2.1 amperes of the current that will this 4.2 ohms receive. Now the current that with this 2.1 ohm receive is 0. Why? Because I have already told you that the diode will block all the current and the current there would be 0. Determine the reading in the amperes. We know that the ampere will read the total current. So total current is 2.1 ampere because the other resistor is not getting any current. So the ampere will read 2.1 amperes of the current. Now we have to calculate the power that is transferred to 4.1 ohms of resistor. So we know that the relation that connects power to current and voltage is P equals to IV. I can use this relation, and I is, we have already calculated, 2.1 for this resistor, and voltage is 9 volt. For parallel combination it is same always. Answer is 19 watt. So the power is 19 watt, and we know we have to answer in two significant figures.